Okay, so this is going to be our notes for 2.1 for stats. And here we're talking about organizing data, and specifically we're going to be talking about using a frequency distribution to do that. Data, when it's in its raw form that we collected, which is either going to be a bunch of yes, no's, rankings of how good a professor was. Maybe it's your height, all the different heights from different people in a classroom. That's all going to be raw data that needs to be organized so we can make sense of what we're looking at. A frequency distribution is a good table that we can use to organize classes of information and the frequency at which those classes are represented. If it's nominal and ordinal, something that doesn't have a scale, nominal and ordinal, remember, are things that can't be ranked or things that can be ranked but don't have a scale like what an inch is or degree of Fahrenheit. Those are things that have specific measurements that allow us to use a different type of table. In these categorical frequency distributions, an example of this would be your blood type. That's going to be a nominal, not ordinal, but a nominal type of data, and we're not going to be able to classify it as good, better, best. We can't say from 0 to 10 is this, so we're left with a categorical frequency distribution. And when we do categorical, the first thing that we're going to do is we're going to tally up how many times we see type A blood, which would be 1, make a different color. That color's too thick. 1, 2, 3, let's see, there's 1, 2, 3, 4, 5. So I should go 4, 5 for that first one. The B's, there's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. You might ask, why don't you just write down the number 7? Well, we're going to do that over here where it says frequency. The reason we use a tally is sometimes the data is so big that we really just want somebody to tally them up to read them off while we make marks. So you could imagine someone's reading through this list, and every time they say the letter O, I'm going to put a tally in the O position and count those up that way. 4, 5, 6, 7, 8, 9. Now there were only 25 data points in this case, so it wasn't too bad to sort through this way, but you could imagine that it might be a lot worse if 2, 3, 4. That would be 9, and that would be 4. This is a good way for us to total up. Did we actually end up with 25? And 5 plus 7 is 12, plus 9 is 21, plus 4 is 25. So that gives me a good sense that I've got all of them. And then it's always a good idea when we're talking about representation like this to go ahead and give us a percentage. What percent of the time did each of these come up? Now it's out of 25, and so we turn each of these into a percent. Divided by 25, 5 is going to end up as 20%, 28%, 36%, and 16%. Telling me, oh, hey, most of the people in this military branch or this inductee class is a type O blood, and so I need to think about that as the type of blood that I might have on storage in case of an injury. So this is what a frequency distribution looks like. It gives me the ability to sort through and look at the data in a big picture sense. Now, when the data is something that's ratio or interval, where we have numbers running from 0 up to 1,000 or whatever that is, we have grouped and ungrouped frequency distributions. When the data range is really big, meaning the low to high number is fairly large, bigger than say 20, or bigger than say even 7, when there's a bigger gap than 7, we're probably going to do what's called a grouped frequency distribution. The smallest and largest possible data values in a class are the lower and upper class limits. The class boundaries are the line that separate each class. And we're going to talk about how to build these as we go, or a little bit later. We have this information about what we call the class width. The class width can be found by looking at the successive lower class limits. When we look at these lower classes, I'll try to explain that width issue to you, and the midpoint is the center of the class. Some general rules: there should be between 5 and 20 classes if we're doing a grouped frequency distribution. The class width should be an odd number. The reason we like that to be odd is when we go to find the midpoint, if the width is odd, the midpoint will be a whole number. If the width is an even number, then our midpoint is going to be a decimal. It must be mutually exclusive in our classes, meaning that a number can't belong to both classes. It can only belong to one class. It must be continuous. You cannot jump over a set of numbers. Even if you say, hey, there's nobody between 12 and 15, let's skip that class. No, you have to have a class with 0 frequency. That's okay. It must be exhaustive. Everybody gets involved. Now, sometimes when you get to the very end of your last class, you're at like 100, and you should go to like 105, but there's a number at like 112, and you realize that's a really oddball number. It's the only one that's out there, and rather than creating 3 more classes to get there and having a bunch of empty classes, sometimes we'll just say 100 plus and have an open-ended distribution. And when that happens, the classes don't have to have the same width, but otherwise they should always have the same width. Okay, we can't have different size classes along the way. One of the big things is to determine what the width should be. You take the range, which is big minus little, biggest number minus the smallest number, and you divide it by how many classes you're hoping to have. Now, it's nice to have the width turn out odd, and so if this comes out as a decimal, first we're going to have to round up. But if rounding up creates an even number, we might go one number higher to try and create an odd number. It's not required that you do it that way, but it's a good idea to help with keeping that odd piece. All right, so let's take a look at this data and let's talk about how to build the grouped frequency distribution. This is the high temperatures for every state in the U.S., the highest temperature ever recorded in all the states in the U.S. Now, these might be different now, but these are what they were at the time. And so we see there's a lot of data here. Our low value is 100 and our high value is 134. And so we want to build a classification system with 7 classes. So the first thing we're going to do is we're going to figure out how wide these classes should be, which would be 134 minus 100. That's our range. And we would divide that by 7 because we're hoping to have 7 classes. Now when I do that, we're going to end up with a decimal here. Let's take a quick look. 34 divided by 7. Oh, look, it's already on my calculator. I've done this question once before. 48.57, or 4.8757, sorry. I'm going to have to round that up to 5. Now, if that rounded up to a number like 6, I'd probably push it to 7 just to get an odd number. But this tells me my class width is going to be 5. Let's talk about how we use the class width to create our groups. Okay. Now, we could build this from scratch, but what we're actually going to do is we're going to come down and look at the class limits that they've built for us. This is what our frequency distribution should look like. In a grouped frequency distribution, okay, we have a few things we have to add, or can add. Class limits, we would start at the lowest number, which was 100. Now, our width was supposed to be 5, right? And so you might look at it and say, but Mr. Welch, we're only going to 104. Well, what you have to realize is that we actually go half a value lower and half a value higher when we talk about the boundaries, because sometimes you might end up with a temperature of 104.2. Well, who does that belong to? It's not less than 104. It's not even equal to 104. It's not 105. Who does it belong to? And so the class boundary is how we can actually see the gap of 5. Okay, that's where the number or the width of 5 comes from. A quick way to get this number is to just do the lower limit all the way down. I would just keep adding 5 to my low end, and then realize if this is 105 here, I had to be at 104 for my upper limit on the other. And then I can add 5. Okay, the adding 5 works on this vertical column. It doesn't work at going across. 100 to 104 is going to have a width of 5, even though if you subtract it, you'd only get 4. Hopefully that makes sense how we build this. Again, with our class boundaries, okay, 100 to 104, well, we're going to extend that half a value each direction, more than what we have in order to create our class boundaries. Then we would calculate our frequency. This is the number. Normally I would do a tally here as well. And that's how I would record, because this is a huge list. I would put a tally in here, a tally column rather, before my frequency. This person who built this table for us has already done the tallying and written down the number. But if you can imagine having one more column in here, I would have a column that has a tally. Because I wouldn't want to go through 50 different temperatures trying to figure out where does it fit. And you're going to want to tally so you can keep track along the way. Okay? Then we have the possibility. So you can either do a percentage. I think on the homework I'm going to ask you to do a percentage column like I did with the blood type. Let me come back here. Having a percentage column I think is really good, and please do that on 2.1. But one of the other things that we will calculate, and there's a reason for this later when we do some graphs, but we would do the cumulative frequency. Now the cumulative frequency just tells me, so far, how many have we hit? Well, so far we've hit 2. After we include the 105 to 109, I would be up to 10. After we add the 18 from the next group, I'd be up to 28. So a cumulative frequency is a way of saying, how much have we gotten through so far? And then 41. Now, why might I do that? Well, here when I hit 48 out of 50, right? 48 out of 50, that's almost all of the states. These last two, I would consider them outliers. I'd say, they're not really worth worrying about. It's probably Texas and Arizona. I'm not too stressed about their high temperatures for one reason or another. But those are just things that you could think about as you do a cumulative frequency. It's just, why would we do that? We would do that to kind of get a sense of where do we say we've basically got everybody. That's a way to say, hey, look, we've accomplished everything. There's also a specific graph where we will do that. Again, there's 3 types. There's categorical for things that are nominal or ordinal. Grouped is when the range of data is too big, meaning you've got like a range of like 20. And you're like, I need to group these so that I can get them into small pockets. And ungrouped is when every data value has its own pocket. So if I said the ages of kids in the classroom, I might have some 16-year-olds, some 17-year-olds, and some 18-year-olds. I really don't need categories for that. I could just do 16, 17, and 18 as their own ungrouped frequency distribution. Well, I hope that helps you get through how to build a frequency distribution, and I hope the notes get you through what you need for a class. All right, we'll see you guys later.